So effective nuclear charge is one of the most important characteristics for understanding the reactivity of an element. And as such, just as reactivity has periodic trends, effective nuclear charge is going to have periodic trends as well. So certain elements, based on where you are on the periodic table, will have characteristic effective nuclear charges. So in many electron atoms, so anything but hydrogen, every electron is simultaneously attracted to the positive nucleus and repelled by other electrons. Right, since the electrons are negatively charged, the negative charge of an electron will be repelled from another electron, but will be attracted by the positive nucleus. If the nucleus is treated as a single positive charge, then we can estimate the effective nuclear charge, which is abbreviated ZEFF. And the equation for that is effective nuclear charge is equal to charge minus S. So S stands for shielding, which is done by the core electrons. So notice here that shielding is always going to have a value greater than 0, a positive value greater than 0. Because every many electron atom has core electrons. I mean, you could say helium has 2 electrons both in the same shell, but when you move past helium, you have core electrons and valence electrons. And the core electrons are what do the shielding. So that means your effective nuclear charge is always going to be less than the actual nuclear charge because of the shielding effects. Now, to estimate the effective nuclear charge, Z is equal to the number of protons, and S is equal to the number of core electrons. So for example, the effective nuclear charge of sodium would equal 11. So 11 protons in it, it's atomic number 11, minus 10 core electrons to give you plus 1. So that's just one way to estimate that effective nuclear charge. And you can do that with all of the elements. Just the number of protons is Z, then S is the number of core electrons. So the periodic trends of the effective nuclear charge is that in a row, effective nuclear charge increases from left to right. So the attraction that the nucleus has on the valence electrons increases as you move left to right. The reason being that the number of shielding electrons does not change as you go across a row on the periodic table. It's the number of valence electrons that change. So each time you move one element to the right, you increase the number of protons by 1. So your Z number goes up by 1, but you're not changing the number of shielding electrons. So your effective nuclear charge basically goes up 1 every single time you move across one element in a row on the periodic table. Now, what's a little harder to understand is down a column. Down a column, effective nuclear charge decreases. The reason can be explained using Coulomb's law. So I'm going to move to a new page for Coulomb's law. So Coulomb's law states that the force of attraction is equal to Coulomb's constant times Q1, the absolute value of Q1 times Q2 over R squared. So Q1, we'll just say, is the charge of the proton. And then Q2 is the charge of an electron. So the force of attraction between the one electron, Q2, and then the number of protons, or the atomic charge, right, when you move across the row, the Q number, Q1 continues to increase each time because you have more protons. So you can think of Q1 just as the number of protons in the atom. Q2 is always just going to be 1 because we're just talking about the charge of one electron. But as I move down the periodic table, in a column specifically, right, so we can compare ones in a column, the number of protons is going to keep increasing, right? So that number is going to get larger. But my distance from the nucleus to the valence electron that I'm concerned about when I'm talking about effective nuclear charge, that's going to be increasing as well. And in Coulomb's law equation, it's R squared. Whereas the charge is only to the first power. So even though my charge is increasing as I go down a column, so is my radius, and radius is squared. So because of that, distance has a greater effect on the effective nuclear charge than the number of protons that you're adding in. So for that reason, down a column, the effective nuclear charge decreases. So in terms of periodic trends, these are the two to remember. In a row, effective nuclear charge increases left to right, and that is explained by S, shielding. And down a column, effective nuclear charge decreases, and that is due to Coulomb's law.